Alright, so we're going to get a point relative to this cube. And we'll also show off a couple ways to debug what you've done. So first off, we're going to add an object in a hidden layer, a cube, scale it down, set its texture to wire. I'm going to name it HL for highlight, and then set its view to wire. And then we're going to do an always sensor, Python controller. So this point is own.world position, own world orientation, dot column 1 times 10. So now we have a point in space that is out 10 units from this object's y-axis, no matter which direction he faces. So this should add this highlight right 10 units ahead of him. And it does. So you can see that point there, and then we can make the guy rotate. So you can see that this point will rotate with him. So no matter where he is in space, this will always be 10 units ahead of him on his y-axis. So we can do that, or so this is the exact same point, but we arrived at it differently. Oh, forgot a end bracket. There we go. So we arrived at the same point differently, but using similar math. So we can move this point up 2 units though, or down 2 units, or to the left 2 units. Oh, that was the right, but there's the left. So we're basically picking a point relative in space using a vector. So for instance, if I add a cube and move it out here, we can get its world location, so 8. And then if I move it up 2, so I'm going to have this up 3 units, so it should be right on top of this cube. Or actually, he's up 2, so up 1 more. Yeah, that should be about right. So there we go. So that's right along the surface of the top of that. So you can predict in where in 3D space the point is going to be. And where is this useful? Well, right now, we can do bge.render draw line. So we should draw a red line to that point now. And we are. So we can use the raycast as well. So start equals own world position. Ray equals own raycast. And start 0. A property we're going to look for, normals, x-ray, and polydata. So now that's a raycast. And for debugging, we're going to add this highlight object. So if ray 0, this means if there's a hit object. And then we move the added object to the hit position. So here's the object that's going to be hit. Okay, we've got an error of some type here. I didn't spell position right. Okay, I forgot to turn this to no collision. There we go. So now we're adding an object at the hit point of the ray. And we'll turn this to 0. So now it'll leave it there forever. Okay. I'm going to make a bullet hole object. So here's our bullet hole. It's not a very good bullet hole, but it's a bullet hole. So now I'm going to replace this HL with plane. And see, it's adding it, but it's not facing the correct direction. Now it should be. There we go. That is how you place a bullet hole. Oh, I have to make it no collision though. There we go. So there's points in space, casting rays, and aligning a hit object to a surface normal. You'll notice that if I rotate this, it's still lined up correctly. We can also have this thing, instead of doing always, we'll do tap. Pew, 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 pew. Rotate a little further. Alright, so there's some Z clipping because it's perfectly aligned to the plane and placed on the plane, so you'll see it's popping through it a little bit. So we do. So now they shouldn't clip through the surface, though they may clip through each other. So there we go. Bullet holes. Pew, 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 pew.